Alright, let's talk about the difficulty when using sine inverse to solve a triangle. I have the law of sines written here, and the reason I'm talking about sine inverse is, let's say we wanted to solve for angle A here. If I wanted to solve for angle A, at some point I would have to take the inverse sine of sine of A to get rid of the sine in front of the A. So to solve for the angle, using law of sines, you'll eventually take sine inverse, and that's why we're discussing why there's an issue with sine inverse. Okay, so something I want you to realize is that any angle in a triangle is between 0 degrees and 180 degrees, okay? So keep that in mind. Whenever we do these inverse sines, we expect an angle between 0 and 180. Now let's take a specific example. When I write sine inverse of 1/2, what does that mean? Well, it means the angle whose sine value, meaning when you take the sine of that angle, you get 1/2. And so if we focus on only angles between 0 and 180, and we look at the coordinate plane here to sort of understand this, I need to find an angle so that when you take the sine of that angle, you get a half. Well, if you think about this angle, and you draw the right triangle, the reference right triangle here, if I want the sine to be a half, that's like the y over the hypotenuse. So 1/2 over 1 is 1/2, so this angle has a sine of a half. But there's also another angle in quadrant 2. Let's use red here. In quadrant 2, this triangle also has a sine of 1/2, right? Because the y coordinate is still positive. And you should recognize that this is a 30, 60, 90, because the short side is half of the hypotenuse, so that means this side would be square root of 3 over 2, and this side would be negative square root of 3 over 2. However, that does not affect anything because we're interested in the 1/2 part of it. So what angles are these? Well, if this is a 30, 60, 90, this blue angle here is 30 degrees, and the red angle here, well, the reference angle, this is 30 degrees, so the red angle is actually 150 degrees. So that means sine inverse of 1/2 in a triangle could be 30 degrees or could be 150 degrees. And so if you enter sine inverse of a half into your calculator, make sure you're in degree mode, you'll see that it only tells you the acute angle, the 30-degree angle. Alright, and that's the problem with sine inverse. Whenever you're using sine inverse to solve for an angle in the law of sines, your calculator is always going to give you the acute angle, and you have to consider that the obtuse angle might be a possibility as well. So let's say at some point you're trying to solve for an angle whose sine inverse of 3/4. If you enter this in your calculator, you end up with approximately 48.6 degrees, but then you have to consider that your calculator is only giving you the angle in the first quadrant. You have to consider the angle in the second quadrant, which would be 180 minus the 48.6 degrees, the supplement of 48.6 degrees, which is 131.4 degrees. So it could be either one, but your calculator is only going to give you this guy. And you have to then investigate the obtuse possibility. So sine inverse, you always have to consider the acute and its supplement, 180 minus that, right? 150 is 180 minus 30.